first unit is the trigonometry unit, or study of triangles. Okay, so the first few lessons, they're going to be a review from the grade 11 stuff. So we're going to start with trigonometry and right triangles, and we're going to do sine law, cosine law. After we finish these 3 lessons, we're going to move on to the grade 12 material. Okay, so these are still covered in the grade 12, but they are kind of a review from the grade 11. Okay, so we did some of them in the review as well, so it's a good recap. So for the goal for this lesson is to find the measure of sides and angles in right triangles using trigonometry ratio, which is SOHCAHTOA. So right triangles have a 90-degree angle. The sum of all angles equal to 180 in a triangle. Capital letters, they indicate angles. And lowercase letters indicate sides. If 2 sides are known, we can use Pythagorean theorem to solve for the third side. And what is the Pythagorean theorem?
A squared equals b squared plus c squared.
No, a squared.
B squared is
A squared plus b squared equals c squared. All right. Now, C is the hypotenuse. So remember that when we're talking about right angle triangle, right, and when we're talking specifically about the Pythagorean theorem, we have the hypotenuse, and the hypotenuse is indicated by C. So as I said on Friday, right, that C doesn't change. A and B, you can call whatever A, whatever is B, that doesn't matter, okay? C is your hypotenuse, and then C squared is equal to the sum of the square of A and B. And this is used to find the third side, okay? So if I know 2 sides, I'm looking for the third, that's what I use. If I'm looking for another side, okay, given an angle on a side or given 2 sides, I can use the trig ratios. Sine is?
the opposite over 9.
Okay. And remember that in a triangle, in a right angle triangle, you always have the given side or the given angle, which is the angle of interest, or the angle that you're looking for, and then you name the triangle according to this angle. The hypotenuse does not change, right? And now according to this angle, this is my opposite, this is my adjacent, right? If I have the angle of interest is up here, hypotenuse is still in the same spot. Now the opposite is at the bottom, and the adjacent is this side. So it depends on the angle given to you. Cosine? And tan is? Opposite over adjacent. Nice. So it depends on which sides I have or which side I'm looking for, then I pick the trig ratio that I need. So remember that this can only be used with right angle triangle. Don't try to use them with oblique triangles because it will not work. So I've already explained this part to you, right? So the hypotenuse is always the longest side across the right angle. Adjacent is the side that touches the angle of interest, and the opposite side is across from the angle of interest. Any questions about naming your triangles? All right. So when you're finding side measure, you're going to label the opposite adjacent and hypotenuse side according to the angle of interest. Choose which trig ratio to use, given the sides you have and want. Write the formula, sub in your values, solve with your calculator. And this is the rule. Unless the question specifies otherwise, you're going to leave your sides to one decimal place. Okay? So all sides should be left to the nearest one decimal, unless the question asks you otherwise. Okay? So let's look at examples, because I can talk all day. If you don't look at examples, it means nothing. So this is your right angle triangle. Find the measure of side P, given that angle P is 60 degrees. So angle P is 60, so your angle P is down here. Where's side P? The opposite, which is MN. Okay? So I'm looking for this side. So first we're going to have to name the triangle. What do we call side P? With respect to the opposite. And the given side is the hypotenuse. Anyone have any problem naming these? I can slow down. All right. So, if I'm looking for the opposite, I know the hypotenuse. Which ratio should I use? Sine, right? Because sine is the one that has opposite and hypotenuse. Okay? So sine is the one that has the opposite and hypotenuse, so I have to use sine of the angle. Sine P is equal to the opposite over the hypotenuse. P is 60 degrees. The opposite is just letter P in this case. And the hypotenuse is 225. Are we okay with this? So what do you do to solve for side P?
To bring the 225 to the left side, yeah.
And then what does it make? What do I do with it?
So multiply with
Multiplication.
the sine.
Perfect. Okay, so because there is a division here, if I bring it to the other side, I have to multiply. So it's going to be 225 sine 60, which equals to P. 0.0, so it's 0.0, right? Because you decide to one decimal place.
Give me 194.
Okay? Because yours is in degree, yeah, so it's 185, 184.9. Can I see your calculator? Just want to make sure that's in degrees. Okay, so you see right here, it says G. So that's not in degrees. And that's, you guys have to be careful that your calculators, I'm going to change it for you, okay? Yeah, 1 second. I'm going to make sure that your calculator says D on top. Yeah, 194.9. Yeah, it's just his calculator had a different, did not have the degree, that's why. Okay, so 194. Make sure that you get this answer on the calculator. If not, call me so I can come and, is it 0.9? 0.85, so it's 0.9. Okay? Are we all good? You got it on the calculator? working on the second one. Angle C is your right angle here. Okay, now I know it doesn't look like it, but this is your right angle. And you know that angle A is 74. Do not ever look at the triangle and say, well, it doesn't make sense. The triangles are never to scale, especially the ones I draw. All right?
That's a right angle triangle?
Yes, this is a right angle triangle, and your C is your right angle triangle. Is your right angle. Okay? So we're looking for side B. So which is AC. So I'm looking for this one. Okay, let's name the triangle. So the one that's 40 centimeter, what do we call that?
The opposite.
The opposite, because it's opposite from angle 74. And then the angle I'm looking, the side I'm looking for, that's the adjacent, right? And the AB is your hypotenuse. So this is your adjacent. So I know the opposite, I'm looking for the adjacent. Which ratio do I use? 10. Perfect. So tangent, so tan A is equal to opposite over adjacent. So now I'm gonna fill in the numbers that I have. So tan 74 equals to 40 over B. What do you do to solve for B?
Switch the place of B and tangent 74.
Okay, so because B is right here in the denominator, right, I need to bring it up to the numerator. So you can do this in 2 steps or you can do it in 1 step. I'm gonna show you the 2 steps, okay? And I'll show you how you can do that in 1 step. So, to do this in 2 steps, basically you're gonna have to first multiply by B or bring B over, and it's gonna be B tan 74 equals to 40. And then because I'm looking for B, that means I have to bring the tan 74 down here and as a division. Are you guys okay with this? Are you okay with that? Okay? Now, the 1 step is basically, I am not showing my middle step here, right? And the way I think about it is because I'm looking at B and it's a denominator, these 2 switch spots. So B comes here and tan 74 comes to the denominator. Okay? That's like skipping your middle step. If you're not comfortable with this, show both steps. Okay? Now, in your calculator, make sure your calculator is in degree and then find 40 divided by tan.
11.5. Yeah.
11.5. And then make sure you report it. You report the units, which I did not do that in the previous. Question. Make sure if they give you like side length, right? If they give you a unit, you have to report your answer with a unit. Are we good with that? Okay, so that's if we're looking for a side length, okay? And I'm given here an angle and a side. Now, I can also use SOHCAHTOA if I am given 2 sides and I'm looking for an angle, okay? So it's the same idea. So you're gonna label your sides, you're gonna choose the trig ratio, you're gonna write the formula, sub the values in the formula. Now, the only difference here, because you're looking for an angle, you have to do the inverse operation, which is sine inverse cos inverse tan. So on your calculator, that would be second or shift, sine or cosine or tan. Okay? So make sure you can locate your second button or your shift button. And then if you press it, it should show you on the calculator something that looks like this. Okay, sine inverse, cos inverse, or tan inverse. Okay? We use the inverse operation whenever we're looking for an angle. So here's an example. So angle C is your right angle, and they're asking you to find the measure of angle B. Angle B is the angle of interest. Name the triangle for me. So name the opposite, adjacent, and hypotenuse. Name the given sides. So CA is what?
Opposite.
Opposite. I care only about the given sides, right? BC is
Adjacent.
adjacent. Okay? Remember that the hypotenuse is across from the 90 degree. All right, now, I'm looking for angle B. I know the opposite and the adjacent. What formula do I use? Tan. Excellent. So tan B equals to opposite over adjacent. So that's going to be tan B equals to 8 over 30. So, you have two options. You can find 8 over 13 on the calculator and write it to 4 decimal places, or you can leave it and then just enter it in the calculator in brackets. So that would give you the most accurate answer if you actually do this. Make sure that your inverse is in bracket. If your calculator is backward, I would recommend that you do 8 over 13 first, find the answer, and then you do shift 10. Okay? If your calculator is straightforward, you're going to do 10 inverse, and then you can open bracket, 8 divided by 13, and then you should find your answer.
Just another question. Can I skip the writing this, the last part? Can I write the last answer? Or shall I add?
This is your showing your steps. Okay?
Shall I show
Yes.
this? Okay.
Yes. I always recommend that you show your steps, right? Especially this one, because this is telling me that you know that you're doing the inverse. Now, you should always, unless the question asks you otherwise, report your angles to the nearest degree. Do not report angles with a decimal. Okay? So what would be your degree for this one?
32.
33, 32, what?
31.6, 32.
Okay. Now, what if I asked you to find angle A?
No, I can 180 minus 90 minus 32.
Yeah. Remember that the sum of the angles inside a triangle equals to 180. You already know this is 90, and you know this is 32, right? So you can do 180 minus 90 minus 32 to find the third one, right? All right. So we're looking to solve for angle R and angle T. Which one do you want to start with?
Angle T.
R. Let's start with R. Okay.
Same.
So let's name that triangle according to angle R. So SR is what? Adjacent. And then RT,
T is height.
excellent. Any questions about naming the triangle, guys? Are we okay with that? This is where, like, if you go wrong with naming the triangle, then your answer is going to be obviously wrong, right? Okay, adjacent hypotenuse, which ratio do I use?
Cosine.
Cosine. So cosine 7 over 15. What's your angle?
62.
Okay, so this is where I asked you previously, what if I asked you to find the second angle? So in this case, to find angle T,
It's 100 over 9.
angle T. Okay, this is an indication that I'm looking for an angle, right? Equals to 180 minus 62 minus 90. What do you get?
28.
And I don't want to hear any of you asking me if you need to show your work when it comes to math, because then I'm going to point at that blue sign on my famous board that says, did you seriously just ask your math teacher if you have to show your work? Right? Because if you don't show me your work, your answer is 0.5 different than what I have. Guess what you're gonna get? Big fat 0. Right? Because I don't know what you've done. Right? If you show me your work and then your answer is a little bit off, you're gonna get the full marks because I know that you followed the right steps. Okay? The answer is worth half a mark. Everything else is worse than rest. All your other work. Okay? All right. Now, the angle of elevation and angle of depression. So a lot of times when we are, in word problems, right, they're going to say a person standing on the ground and looking up to the sky, and there is a, don't know, a bird, and the angle of elevation, and the angle of elevation so the angle of elevation from that person to the bird is 40 degrees. Okay? So that angle of elevation is always measured from a horizontal line. Okay? So if I'm standing here and I'm looking up, right? And I'm saying that the angle of measurement, the angle of elevation is 30 degrees. That is measured from the horizontal line that's coming out of my eye of sight. It's an imaginary line. Okay, because there's no actual horizontal line that's coming out of my sight, right? So if I'm forming this triangle, there is going to be a horizontal line coming out of my eye of sight, and there's going to be a line that's forming from my eye to the object that I'm looking at. And that angle that I have here is the angle of elevation. Okay? So, this is the eye of sight, or the line of sight. And then, looking up at the object, this is the angle of elevation. Okay? And if I'm looking down, it's the same idea. Okay? Out of the line of sight, down to the object, that's my angle of depression. Okay? There's other words that sometimes they use instead of elevation and depression. They use inclination sometimes. Okay? But mostly you'll see these two words. And it's always measured between the horizontal line, okay, and down or up. So what I would like you to do right now is I would like you to take a minute to try to draw the graph of the next exam. From the top of a bridge, Maria looks down at a sailboat at an angle of depression of 15 degrees. The bridge is 18 meters above the water, Calculate the horizontal distance from the bridge to the sail, from the bottom of the bridge, obviously. And tell me where your angle is and where is the 18 feet. All right. So, Maria's standing at a bridge, and she sees a sailboat. The triangle, my triangle might look a little bit different than yours, as long as we end up with the same angle, like the angle and the sides are in the same location, okay? To each other. So, I have Maria, and Maria's standing right here on top of the bridge. Right? And Maria sees a sailboat, and the sailboat is right here. And I'm trying to figure out how far is the sailboat from the bottom of the bridge. Okay? Now Maria is looking down at the bridge. So she's looking down at the bridge, and then the angle of depression is 15 degrees. So obviously I'm going to have a triangle here, right? Now where would I put that 15 degrees?
At the top?
Bottom, top.
From the top?
So,
From Maria, no?
so it's an angle of depression. Where is the angle of depression measured from? From the horizontal. Do I have a horizontal here? So this is not your 15 degrees. Okay? Because this is not measured from the horizontal. I don't have a horizontal line there. If you want that to be a horizontal line, or if you want to put the 15 degrees, you're going to have to draw a horizontal line coming out of Maria's eyes. And then now your angle of depression to the sailboat is 15 degrees. So your 15 degrees is right here outside your triangle.
So it means 15 down too.
Where?
The sailboat.
At the sailboat, you have 15 degrees. Now, why is that? Because horizontal up. So there is a rule, and the rule is the Z rule, or I forgot the name of the the something angle, complementary angle, or whatever it is called. Okay, I have to look up the name. So if you have a Z rule, so if you have two lines that are parallel to each other, and then they're joined by a diagonal line, right? The Z rule says that this angle right here is equal to this angle right here. Okay? So if you look at this one here, I have my Z pattern, right? And that means if this angle here is 15, then guess what? This angle here is also 15. Okay? So Another way, if you can't remember this, all right, if you look at your triangle, and this is 15 degrees, right? This and this together, they form 9 because I have a horizontal and a vertical. And every horizontal and vertical make a 90 degree, right? So if this is 15, then I can find the other angle by subtracting 90 minus 15, okay? Which also gonna work out to be exactly the same. Now, let's say if I have it this way, okay, and I figured that if this is 15, that means this is 15. This is the height of the bridge. It's 18 meter. Okay? So according to this triangle, I am looking for how far is the base of the bridge to the sailboat. This is 15 degrees. What do we call this? Opposite. And what am I looking for? The adjacent. So what do I have to use? So tan 15 is equal to, actually let me write the formula first because I tell you to. Tan, what do you want to call it? S equal to opposite over adjacent. So tan S equals to 18 over adjacent. What's S? Sorry, that's 15. Okay, so what do you do now? Yeah. So that's going to be adjacent is equal to 18 over tan 15. Which is going to be 67.2. This is a word problem, right? Word problems must have a therefore statement at the end. Okay? So you must end your question with the therefore, whatever the answer is to the question. So therefore, the sailboat is 67.2 meter away from the bridge, or from the bottom of